So the big picture for this lesson is the triangle proportionality theorem and its converse. So the triangle proportionality theorem says that if you have a line parallel to one side of a triangle intersecting the other two sides, then it divides the two sides proportionally. So in this situation, if segment AB is parallel to segment EC, then the segment DE to EA equals segment DC to CB. So that's how you make your proportion for the triangle proportionality theorem. And so basically you can use this information to solve for unknown measures in the triangles. And you can see here, it's 3 to 5 equals LK to 10. You just cross multiply and solve. In this example, the concept is the same, but the challenge is you're given the whole segment YT here, so you don't know YZ. So you can represent YZ because you know the X. So it's 30 minus X for the YZ. That makes your proportion a little more complicated because you have 30 minus X to X equals 16 to 8. The converse of the triangle proportionality theorem says if a line divides two segments of a triangle proportionally, then it is parallel to the third side. Basically what you can do is you can use a proportion to determine whether or not you have a segment parallel to a side of a triangle. So instead of writing the proportion, what you can do is you can just find the two ratios and see if they're equal. So AB to BC, that's one ratio, that's 8 to 4. AE to ED, that's 9 to 5. Well, those aren't equal, so you know that this isn't a parallel situation. If the ratios were equal, you would know you had a proportion situation, and you could say the segments were parallel. So here's another example. You have to solve for the AB segment first, that's 21. So you do 9 to 21 and 6 to 14. Those both simplify to 3/7, so it is the same ratio, and you can say that the segment is parallel. So that's what you're doing in this lesson. You're going to be dealing with proportionality, and you're going to use the triangle proportionality theorem and its converse. That's the big picture.